So I have here a paper on counter-deception, Hewer's review of biases and their implications for deception and stellar metamorphosis. So basically the abstract here goes, perceptual biases in estimating probabilities, and biases in evaluating evidence are presented with their implications concerning the continuation of modern astronomical and astrophysical deception. For those who are new, the main root deception in astronomy is that astronomers believe stars to be mutually exclusive of planets. For those who are new to this, it's a major astronomical deception, and when you look at the history of it, it kind of sticks out when you start to realize what's going on here. But for new readers, it has been discovered that planets are older stars. Planets and stars are the same objects. Yet the biases plaguing astronomers and astrophysicists continue to keep the deception that a planet is something mutually exclusive of star indefinitely. This is from Richard J. Hewer Jr., Cognitive Factors in Deception and Counter-Deception. And the experience portion is my own. So this is pretty advanced counterintelligence, counter-deception type stuff, but it definitely has a lot to do with what I've been working on. Hi, Celeste. Hang on, this one's going to take a little while, but I'll do my best. Bias number 1. Perceptions are influenced by expectations. More information and more unambiguous information is needed to recognize an unexpected phenomenon than an expected one. For instance, if something you expect to happen happens, you don't need that much information to further confirm that in your mind. Your perception will already confirm it. But if you find something that's unexpected, you need a hell of a lot more information to battle that preconception. So your perception is what sets the tone for what it is you accept to be possible, regardless of if the information is separate from you. It's your perception that makes that so. And the implication for that it's far easier to reinforce a target's existing preconceptions than to change them. And that's a very powerful tool that a lot of people can use. I know I was watching a lot of murder shows where somebody would be interviewed by the cops before they read their rights and been told, they can get a lawyer or whatever. And the cop would play like their friend, when they interrogate them. Like, how you doing, yada, yada, be all nice and whatever. And if you can keep kind of the preconception that, they're your friend, they're there to help you, then they can get a lot more information out of you than if they were to, play the bad guy and then the person ends up clamming up or whatever. And the existing preconception can be like that. If you can find where their preconception is, you can get a lot more information out of them versus, railing against what they believe to be true to begin with, and then you have a more difficult time interrogating your target. Concerning this understanding, the unexpected phenomenon is that a person not holding an official degree in any science should make a grand scientific discovery. So more unambiguous information is needed to confirm this. This is why I'm writing so much about how the discovery was made and what its implications are, and trying my best to develop it and figure out where, when, how, and why, and which academics got it all wrong. I'll probably need to write thousands of counter-deception papers and papers outlining the importance of the discovery just to show a major scientific discovery has been made. And this goes back to, if I was an academic and I, made a discovery, I wouldn't have that huge mountain of stuff to go over. Because I'm not an official academic, because I'm not an official title-holding person that works at a university, I have a much higher mountain to climb because of people's preconceptions with the reality that a non-scientist or a non-person could make such a grand scientific discovery. So they have to get over that hump a lot higher with me versus if I had an official standing at some university somewhere, or if I had many decades of teaching students, and then I said that or whatever. But it says here, the overwhelming majority of degree-holding individuals have very strong preconceptions that run counter to what has happened. Astronomers, physicists and geologists are still ignorant of the discovery because it still hasn't been acknowledged. And I have here as of March 23rd, 2019. So it's still been a whole year after this paper is even written that astronomers still haven't acknowledged the discovery. Bias number 2. Perceptions are quick to form but resistant to change. Once an impression has been formed about an object, event, or situation, one is biased towards continuing to perceive it in the same way. The implication is it's far easier to reinforce the target's existing preconceptions than to change them. Ability to rationalize contradictory information may offset risk of security leaks or uncontrolled channels. And this has to do with collecting information, and we'll say, for instance, I'll just read this out. My experience on this specific avenue is this is a very powerful problem in astronomy. I say powerful because as children we are conditioned into believing stars and planets are different. Well before any graduate work is done, before any college classes are taken, before any high school physics examinations are given, before middle school occurs. The perception of a star being mutually exclusive of a planet is a perception that is molded in elementary school. We are told the sun is a star and the planets orbit stars. The truth is that the planets, as they are called, are the old, highly evolved suns that no longer shine and are all different ages and stages to their own unique evolutionary history. So not only is a deception quick to form, but it happens in the minds of a child, someone who is also quick to learn. And that's basically it, really. When you're a kid, when you're, 5, 6, 7 years old and you're in elementary school, and the teachers tell you that the Earth is a planet that orbits the sun, which is a star, you tend to keep that preconception for your whole life because it's molded in there. You're trained to believe that from the very beginning. It's long, long, long before you go to college. That preconception is very, very powerful. It's imbued inside of all of us. Every single elementary school, middle school, across the entire planet teaches the Earth is something else other than the sun. Think about how hard something like that is going to be difficult, how difficult something like that is going to be to change. To explain the second half of the implication, rationalization of contradictory information is easy to do. Oh, it's on Vixra, it wasn't peer-reviewed, so it cannot possibly be correct. That's their saying. They say that odds. Oh, has it been peer-reviewed? Well, then it is an incorrect information. It's probably untrustworthy or whatnot. It contradicts what we have always known to be true even as children. See, it is very easy to rationalize away contradictory information when it both disagrees with deep-seated and early molding of preconceptions and rationalize away channels that are uncontrolled, not peer-reviewed. So basically, it says here, this is what people say when, hasn't been peer-reviewed as a cop-out. The peer-review system of publication is the controlled channel. To expect contradictory information to appear on controlled channels is irrational, and even if it does, it is easy to rationalize away as being incomplete, false, or misguided because it does not match what the preconceptions are. And I talked about that in an earlier video. What academics want, what a lot of educated people want, is they want control and they want power over specific channels. They don't want you to step out of bounds with what they accept to be true. They want to hold all the avenues of research. They want to have all the channels under their thumb. So if you have something important to say, they can, kick you out of their own little group because, they don't want to have their own ideas or their own preconceptions threatened, in other words. They want to be able to control the channels of information flow. And for an uncontrolled channel such as Vixra, that's really, really bad for them. And how they say, it's probably a place where you can't trust the information. That's not true at all. What you should be looking at is the system where they control all the information, and then they tell you what they want you to believe or what they want you to see. And they kind of keep your mind like this. And that's where you should be really concerning yourself with, is the people who are obsessed with control and want only information to go through control channels that they control. You see how that works? It's kind of like communism in a way. And that's scary. I don't want to talk about that. Bias number 3. Initial exposure to ambiguous or blurred stimuli interferes with accurate perception even after more and better information becomes available. And the implication for this is that impact of information can be affected by the sequence used in feeding it to a target. In my experience, I'll just go ahead and read this out to you. This bias I've come across quite often. Just presenting the theory to people online shows it all too well. If I'm to present blurred stimuli, such as removing the clear delineation between brown dwarf and planets, their arbitrary mass cutoff for definition's sake. See, they define planets and brown dwarfs as a brown dwarf is 13 Jupiter masses, and then a planet is less than 13 Jupiter masses. That's how they delineate it. By stating that brown dwarfs lose mass to become high mass Jupiters, then their acceptance of the idea is more reasonable. So the closer I present more clear information, say for instance I take the brown dwarf and I make it lose a little bit of mass and become a large Jupiter, then it's more believable. It's a less blurred. If I blur the stimuli to a greater extent and try to warp the perception by expanding the conclusion to include the fact that high mass stars lose almost all of their mass to become high mass Jupiters, then their accurate perception of the same concept becomes reduced. So what I'm saying is, if I were to present the same information, the same type of logical conclusion where the brown dwarf loses mass to become a large mass Jupiter, if I move that mass a little bit higher, say maybe to a red dwarf, and I say, well, a red dwarf loses all of its mass and becomes a large mass Jupiter, to an astronomer's mind, that will become more blurred. The stimuli is like, what? No, that can't happen. And that's the problem. The more blurred you present the stimuli, the more the harder it is for them to get it. And if you blur even more so from something like the sun size down to something Mercury sized, the astronomer will become completely lost. The stimuli is too great. I can't present the idea like that. I can't just throw this entire graph in their face and say, well, this becomes this down here. They can't handle that. The stimuli is too great. You have to come in little baby steps with them. And I also have here, the sequence of the new stimuli presented as it approaches the truth is less accurately perceived due to pre-existing ideas that are already considered unambiguous, regardless if that is the real deception. It is best to present the new information in an agreeable manner first, rather than completely unwarp the perception of the academic in a single instant, so they cannot turn back around. It's like leading somebody out of the cave in Plato's Allegory of the Cave. The closer their eyes get to the light, the more they have to adjust. Throwing all the light on somebody at once is blinding. I've made this mistake so many times. It doesn't work. You can't sit there and throw heavy truth on somebody because they'll just shut down on you. They won't listen. You have to present it in little baby steps because it's just too much for people to actually understand something like this. When you've been conditioned your entire life to believe Earth to be mutually exclusive of something like the sun, ever since you were in elementary school, and then you wake up and realize that all those little bright dots in the sky are young Earths, it's just too much. People can handle it, especially academics. Says here, yada, yada. As a side note, some academics like their mental cave. They find security and comfort in delusion and accepted deception. That's a big mistake I also make. We cannot be too careful in assuming that astronomers want truth, when in fact they might actually just want acceptance into a science group, and truth is secondary. That is the conformity versus non-conformity argument, though, and I won't be getting into that. So a lot of academics, I thought that a scientist was somebody who was, after the truth and after the facts and all that stuff, but a lot of the times they're just after security and safety. and they will sacrifice truth for security and safety. And that's the big battle between freedom and security that we're facing today with this virus crap. Is how much security are we willing to have versus our freedoms taken away? And I see a lot of old school quotes on the internet that I read a lot of, but basically there's a good balance between the two. But I mean, if you sacrifice security for freedom, then usually you just end up losing more and more and more freedom, and it doesn't become a very good place to live in. And with academics, it's with truth and security. Academics are more concerned with their paychecks, their tenure, their feeling of importance, their sense of community versus truth. They'll throw truth under the bus if it means they get, a steady paycheck. Sad truth, but that's just how it is from what I've learned. Especially when, it's security. If they have entire careers based off them, teaching specific information and that information is wrong, then the credibility game plays in and it's just a big house of cards. Bias number 4, probability estimates are influenced by availability, how easily one can imagine an event or remember instances of an event. The implication is that employees of watch offices will generally overestimate the probability of whatever they are watching for. This leads to the cry-wolf syndrome. Cases of deception are more memorable, hence more available, than instances in which deception was not employed. My experience is that major scientific discoveries are extremely rare. Their availability in someone's memory is therefore very low. As well, they probably cannot even imagine what such an event would look like. Academics have been conditioned into believing that major discoveries are easy to predict. It is a whole bunch of people agreeing with each other at the same time after having spent billions of dollars and having had published a paper which has hundreds of names attached, which is simultaneously heralded as valid the very second the publication is made. As if discovery throughout history had the same backdrop. So basically the implication for this is we overestimate something that we have experienced in our own lives versus what has actually happened in the past. A lot of academics these days, they don't realize that, discoveries are heralded in when we look at the past, when we look at, the history books, and we view it from our lens, from a modern lens. But if you were to live back then and you would be like, wow, this is a major discovery, why aren't people sharing this? You'd realize that discoveries just don't work like that. A major scientific discovery isn't accepted in its time. It's not like there are hundreds of people who have spent billions of dollars. It's usually, from what I've read, it's just a single individual just working stuff out and figuring stuff out and writing it down. There's not this huge experiment going on where they need a huge government to fund a whole bunch of stuff. But anyways, I don't want to read all that out to you guys. See, bias number 5. Probability estimates are anchored by some natural starting point, then adjusted incrementally in response to new information or further analysis. Normally, they are not adjusted enough. The implication is that it is easier to reinforce the target's existing preconceptions than to change them. Of course, we already went over that twice already. And this is very important. The starting point from an academic standpoint is that their education will not lead them astray. That's their starting point. They don't believe that becoming more educated will get them more off the tracks and off the deep end. This is the problem. Their education holds the deception anchor that prevents them from understanding how stars evolve, which is how planets form. They have separated in their minds star from planet, thus there is no way to adjust the new information garnered from the exoplanet, which is evolving star data. Academics just chug along with the same assumptions, gaining more and more confusion as the data rolls in. And we can see this. Astronomers are stunned. Astronomers are baffled. Astronomers are confused. There goes that theory. There goes that model. Oh, they don't know what they're talking about. You see it in all these publications online from various magazines. These astronomers, they're having a very difficult time. And it isn't that the information is false, that these observations are false. The reason why they're having a difficult time is because their preconceptions. They don't realize it's their education that's preventing them from learning. Again, it is easier to reinforce a target's existing preconceptions than to change them. When you have groupthink via peer review, which is the controlled channel, also preventing the change, naturally no incremental adjustment can occur at all. Peer review makes it so that preconceptions have to fail spectacularly and all at once before any fundamental change can be made at all to account for any new information in a rational manner. In essence, there's a giant dam that has a whole bunch of water behind it, disconfirming evidence. We'll call it disconfirming evidence water. And when the dam breaks, all that water goes down into the valley. But until that happens, then no change actually occurs. And this is exactly what's happening. These astronomers, they're learning about all these exoplanets that are doing all these strange things, and they have no explanation for them. And their theories are just failing left and right. So the water behind the dam is building up and building and building, and eventually that dam's going to break. And it's going to be pretty spectacular. But that's the only way it can really change. It has to just go all at once, because the peer review system is the controlled channel. They're preventing it from changing. That the peer review system is the dam. But if it didn't have that dam there, then the change would occur. It would flow. It wouldn't have to fail spectacularly. See, bias number 6. In translating subjective feelings of certainty into a probability estimate, people are often overconfident about how much they know. Gosh, that's astronomers in a nutshell. Overconfidence exacerbates the impact of all the biases, and it leads to self-satisfaction and lessening of efforts to improve judgment. This is the role graduate education fulfills in astronomy and astrophysics and geophysics. The academics transfer all their hard work and dedication into feelings of superiority over others, not realizing they are building a large confidence off nothing in particular. Their arrogance blinds them. The deception is still there, only reinforced to the point of being impossible to expose at this point. The academic's ability to perceive that they have been deceived is lessened considerably, and evidence to the contrary is ignored and brushed under the rug. So basically, they take an assumption, they take their preconceptions, they build an entire worldview on it, and to hell with questioning anything they've been trained to believe is true, because they're the ones that are educated. So it's like this perverse feedback loop where their arrogance and their continued higher and higher education just blinds them more and more and more, and they don't even realize it. And here is another bias number 7. People have more confidence in conclusions drawn from a small body of consistent data than from a larger body of less consistent information. The implication is the deceiver should control as many information channels as possible to reduce amount of discrepant information available to the target. Deception can be effected even with a small amount of information. Well, that's interesting, because the peer review system, they try to make it to where only the highest journals, the highest ranking journals, are the ones that contain only the accurate information. So they try to control those channels. They try to narrow them down to make sure there's no stragglers that are being dissenting and questioning their results. And from my experience, this is a bit technical here. The small body of consistent data is the mostly flat disk the planets sit on in reference to the sun, and the fact that the large bodies all orbit the sun in the same direction. The large body of less consistent information is that a large percentage of exoplanets found by the Kepler Space Telescope and others contradicts this. Many do not orbit the host in flat disks, nor in the same direction. Many of them are retrograde. And of course, they try to brush that under the rug. Try to look up online how many exoplanets are orbiting retrograde. You'll find maybe six to 9 of them, and I know there are hundreds of them, but they don't like to speak up about that. That's the gorilla in the room. And I have here, if you want to give confidence to astronomers and astrophysicists, give them very little data to show how correct they are, and ignore the larger body of data that is inconsistent with their beliefs. This is how the concept of the Fulton gap arised. There are actually hundreds of exoplanets discovered that sit directly between 1.5 and 2 Earth radii. There is no gap. Deception can be effective even with a small amount of information, just as long as information channels are reduced, which is of course a given, as peer review drastically reduces the number of available channels. All Fulton had to do was pick a little data, make sure it was consistent, produce the data on a single channel, which is one journal, one paper, and voila, deception that a gap exists. Astronomers do this a lot. I could list hundreds of examples. This is just one case I remember. The Fulton gap is the belief that somehow the exoplanets, there's less exoplanets between 1.5 and 2 Earth radii, that there's a gap. But when you look at the data, when you stretch it out, there's no gap there. It was just invented stuff. And we all know better. It's a smooth transition. And here's the big one, what I call the big one. People have difficulty factoring the absence of evidence into their judgments. For the deception planner, errors of omission will be less serious than errors of commission. To detect deception, analyze what inferences can be drawn from fact that some evidence is not observed. This is the big one. There was no evidence that stars remained hot, big, and bright for the majority of their lifespans. As it would be obvious if astronomers were to see them, then the counter evidence would have been apparent. It was an absence of evidence that they failed to account for. The astronomers and astrophysicists drew up conclusions concerning the entire lifespans of objects under the assumption they had all the evidence required to do so. They never considered that evidence required to draw up an accurate analysis of the situation would be out of reach for a long time. Now that the new evidence is coming in, the preconceptions are still there, thus leading to the next bias. Impressions tend to persist even after all the evidence on which they are based has been fully discredited. And I have here, impressions tend to persist. You cannot unring a bell. So I'll just go over this bias number 9 really quick. It's basically the end of this paper. You guys can read the rest yourself, but the truth is that falsifying, discrediting, and debunking ideas, it isn't enough. Because what happens is preconceptions, they persist for a very, very, very long time. You could debunk, you could falsify, you could discredit all day. But if that perception is still there, if people's preconceptions are still there, then it doesn't matter how much falsification you do. It doesn't matter how much evidence you've collected that contradicts what's being taught. It's irrelevant. No amount of evidence is going to show that the information that contradicts what the preconceptions are. It's never going to do that. The astronomers, it doesn't matter how much information contradicts their beliefs. They have to get rid of their preconceptions. See, they have to go inside their own mind and dig out those preconceptions. And that's almost impossible to do. The only way you can really do that is to have them retire and to do something else with their lives. All right, guys, I think I made this talk way long enough. Later.